You can watch this video to get a more of a visual on how to use the microscope. In our next video, we're going to go take a look at the concept of magnification. So magnification is what microscopes help us do. They take something that looks small and make it look bigger for us. That's what it's called. That's why we call it magnification, to magnify, to make it look bigger. So when we look at a compound microscope, the compound microscope magnifies twice. There's two lenses, pieces of glass that are shaped a certain way, to bend light a certain way, to cause something to look bigger. Sometimes lenses can do the opposite. They can cause something to look smaller too. But we're going to take a look at magnifying glasses. So here we have our ocular lens or eyepiece lens, which is always 10 times. And then you can have an objective lens. Now for us, we have 4, 10, or 40. Some microscopes even have 100. But the main point that I want you to understand is that the eyepiece lens magnifies by 10. And then you have a choice of 3 others, 4, 10, and 40. And the total magnification would essentially be a multiplication between your 10 times and your objective lens that you're looking through. So if you're looking through the 10 and then through the 4 times, you have 10 times 4, which is 40, or 10 times 10, which is 100, or 10 times 40, which is 400 times. So again, you are magnifying twice, once with the eyepiece and once with the objective lens. And for us, our eyepiece lens is always 10 times, and then the objective lenses that we have, it's written on them, 4, 40, or 10. So just make sure you take a look at that. Some of them have different colored stripes to show you which one you're looking at as well, in case you don't see the numbers. So how do you find the total magnification? Well, to find the total magnification, you have to find the power of the objective lens you're looking through. And so it's usually written on the objective lens itself. And then you also have to take that power and multiply it by the power or the magnification of the eyepiece lens, which in our case is always 10 times. So suppose you want to find the total magnification at low power. Well, at low you have 4 times. The eyepiece lens is always 10, so your total magnification is 4 times 10, which is 40. You can try the medium and high based on the previous information you had been told. Pause the video, try it yourself. After unpausing the video, this is what you should have gotten as your answers. Medium is 10, eyepiece is always 10, so 10 times 10, 100 times that medium power for your total magnification. At high magnification is 40. Your eyepiece is always 10. 10 times 40, 40 times 10 is 400 times total magnification. And that's how you would calculate the total magnification of your specimen under the microscope. So take a look at what's happening as you're going from high power to low power to medium power. So what happens is the power of magnification increases. There's 2 choices here. The higher the power, the less of the object you can see. The lower the power, the less of the object you can see. So this here is at low power, this here is at medium power, and this here is at high power. So notice that as you go from low to high, you see more details of a smaller area of your specimen. So here you can see the entire specimen from this loop all the way down to this point here. But as you zoom in, now all you can see is you zoomed into this area, so you can only see that small area. You're missing this whole other segment here because you zoomed in more. And if you zoom in even more, now you see even less of it, you just see this segment here, because you zoomed in more. So yes, you see more detail of that segment, but you see less of the organism overall. So the higher the power, the less of the object that you actually see. You see less of the entire organism because you zoomed into a more specific part of the specimen. So keep that in mind as you're zooming in to see your cells. You might see a whole bunch of cells at first when you're starting at low power because you're not zoomed in. But as you zoom in, you'll see less and less until you zoom in specifically to the one cell you're looking at or to one little part of the cell that you're looking at, but you see more details there. So in the next video, we're going to take a look at what's called estimating cell size. What we saw in this video was magnification. In the next video, we're going to see how do you estimate the cell size based on what you see under the microscope. And when I say cell size, I mean the actual size of the cell that you're trying to observe.